Hey guys! So, today I will be doing a video on local and absolute extrema. Joining me today is Len in his deep voice.
Hello, it's me.
And me, my high voice. Anyways, let's get into the video.
Number 1. Extrema. Extrema are points that exist as the maxima and minima over the entirety of the domain's function, or a given interval in a graph. The first one is called maxima, which is the maximum or highest point, and the second one is called minima, which is the minimum or lowest point. For example, y equals cos x. As you can see, based on this graph, it has a maxima and a minima. Number 2. Local and absolute extrema. Local extrema are points that represent the maxima and minima of the domain's neighborhood, but in some cases, it may exist as the absolute extrema. The absolute extrema are points that represent the maxima and minima of the domain's entire function if there is a given interval, but in some cases it may exist as the local extrema. For example, this equation y equals to x cubed minus 3x squared plus x plus 4 has a local maxima and minima based on this graph. However, based on this graph, if we are given the interval -1 to 3, we'll be given an absolute and local maxima and minima.
Thank you, Len, for explaining these wonderful terminology to the audience. So I'm going to explain the steps to find the extrema with a given function. Let's get to it. So the first step, you want to find the critical points, which is essentially when the first derivative equals to 0. So I have my given function. I'm going to solve when the first derivative equals to 0. Then put them together, you'll be given a first derivative function, which is 3x squared minus 3. We are keeping this marked for later because this is a really good tip I have. So now we can factor this even further to find the roots of it. So that is when, hence your critical points, your possible critical points, PCP, the acronym, would be x equals to plus minus 1. Now, the second step is finding the second derivative of the given function. So you can do that, but this is what I do in my calculations. You can just find the first derivative of this first derivative function. So the second derivative of this function, so follow the same rule again, because this can be solved using power rule. So bring the 2 down, and then you'll be left with 3x. And since -3 does not have an x with a degree, it will become 0. Hence, this will be the second derivative function, which is 6x. Now, you'll be thinking, what are we going to do with this function? How is it going to help us? That's a great question, which is why I'm going to bring step 3 into this. So, the third step is to classify the type of critical point in this. So you have 3 options. Option 1, if the second derivative is more than 0, then it is a local or absolute maximum. Option 2, if the second derivative is less than 0, then it is a local or absolute minimum. Now, the third option is if the second derivative is equivalent to 0, then it is an inflection point. So it's basically a point at which the curve changes. So basically when the curve is like this is the inflection point. More details will be going on into it by my friend Ronan. So take it away. Now, I am going to classify the points that we have found on question. So substitute x equals plus minus 1 into the second derivative function to find out what it this. Now you can safely assume this is the local maxima and -6 as the local minimum. Now you guys will be thinking, what is absolute? Okay, you can only get absolute maximum minima if the function is given with a given interval. So an interval is basically a set of numbers that lie between two numbers. So for example, this function's interval would be 0 and 5. You want to sub the intervals into the second derivative to find out whether they are maxima, minima, or an inflection point. So when subbing 0 into you get 0, which is an inflection point. And when you substitute f double prime 5 to the function, you'll be given 30, which is more than 0. Hence, we can assume this as a maximum. How to tell the difference if a point is either a local or absolute maximum or minimum? Well, it depends on the values that has been solved. So you see, when we solve for x equals to 1, we are given the value 6, which is more than 0. Hence, we can assume this is a maximum. And we were also given an interval 0 and 5. So we substitute 5 into the second derivative, we are given 30, which is also a maximum. Now, to tell the difference, you see 6 and 30, right? 30 is more than 6. Since 30 is more than 6, you can safely assume that the x value 5 is actually the absolute maximum, and the x value 1 is a local maximum. So, I've written out 3 questions that highlights in this lesson. Before we get started, if you want to pause this video right here and just solve these equations by yourself, you can, or you can just let this video go on with me just solving these questions. Yeah, 5 seconds to decide. In 5, 4, 3, 2, and I'm gonna go. So, find the local and absolute extrema of this graph. So the first one we can see here is the local maximum, which is right there. Then the second point is right here, which is local minimum. That's the answer for the first question. Now, second question. Find the local extrema of this function. So, this is the answer for question 2, finding the local extrema of this function. Now, the last question. I got my third question. I had to erase my old answers. I'm so sorry, but I needed space. So, let's get to it. Find the first derivative of this function. So now we've solved for the first derivative. I've marked it. Now let's solve for the second derivative. So I've already started writing out these variables. second derivative of the function, which is 40 over x plus 4 in brackets cubed. Now we're going to calculate the critical points, which is from here. The roots that we've already found from this value here, I'll just straight away write the answer. Which is negative 4 plus minus 2 squared by. Erase everything and return the main information. Now, the possible critical points are x equals to 0.47 and negative 8.47. Now, because we were given the domain, this value, negative 8.47, is not valid within this calculation. So you do not need to use that for your calculation. So we found the extremas. Now we're going to classify them. This is an absolute maximum. This is a local maximum. And this last one is the local and absolute minimum. So that's the answer for this question. Thank you so much for watching. I hope you guys loved the video.